Hello all, welcome to the second part of the regression time series model. And in this session, we'll be taking care of looking at the evaluation metrics, and then we'll end with the forecasting methods and feature engineering. And I'm Aditya, and this would be the continuation from the session from Sujan. And looking at the evaluation metrics for regression models, we have four main evaluation key metrics. The first one would be mean absolute error. So mean absolute error is calculated through this formula, which is 1 by n and summation of I equals 1 to n and yi minus y cap I. Now mean absolute error measures the average absolute errors between predicted and actual values, and it is focused on scales. The second evaluation metrics would be mean squared error. Now mean squared error is similar to the mean absolute error, but the value is squared so that it amplifies larger errors by squaring them so that we can get more insights into outlier impacts. Now the third evaluation metric would be root mean squared error, RMSE, and it calculates and evaluates based on the square root of the mean squared error, and it aligns units with the data, and it simplifies interpretability. Finally, we have the R squared error. It indicates the proportion of the variance explained by the model where values are closer to 1, which imply a better fit. Now looking at the forecasting methods in time series, we have moving average, autoregressive models, autoregressive integrated moving average, ARIMA, and seasonal ARIMA, which is also known as SARIMA. Looking at moving averages, it basically smooths the data and gets like an average over a set of period of time to help and plot trend lines and reduce seasonality. Looking at autoregressive models, it is a simple model which uses past values for prediction, and it creates correlation between data points to create a lagged correlation metric. And next would be ARIMA. ARIMA combines AR and moving average with differencing for non-stationary data. ARIMA and SARIMA could also be considered as a kind of AI model, not fully functional AI model, but a time series AI model. These are related to the LSTM architecture. Next, coming to Sarima, it adds a seasonal component to Arima, which is a little effective for data with repeating seasonal trends. Now, finally, we'll look at the feature engineering for time series. One would be lag variables, it uses previous time points as features. Next would be rolling statistics, it calculates moving averages, variances to capture short term patterns. Next would be differencing. Differencing would subtract current in previous values to achieve stationary in data. To summarize whatever we saw in the past part 1 session and this part 2 session, time series regression analyzes data over time, and it could be of great use in finance to predict patterns and forecast trends. One of the key components we saw throughout these two sessions would be trends, seasonality, cycles, and irregularities. From the coding or technicality perspective, we saw linear regression, polynomial, logistic regression, alongside with key evaluation metrics like mean absolute error, mean squared error, RMSE, and R2. And we also saw some models for feature engineering, and then key components like moving averages, ARIMA, and SARIMA. Thank you all. We'll connect in the next session.